Let's wait for 2 minutes. After that we will start the session. Okay, then let's start the session. My name is Satyavikram Pratap Singh, and I am your TA for the today's session. That is of the course that is Smart Grid Basics to Advanced Technology, and your instructors are the Professor N.P. Padis sir and Professor Premlata Janana. And I am PhD student in IIT Bombay from the Grid Integration Laboratory. Right. Let's start the session. I'm starting the session. Here the flow of the content of today's will be such that smart metering. Initially we will see that and its infrastructure first, and second we will go to the solar PV system. We will study some of the basics, and after that we will see some of the questions and the graphs related questions. Third, we will go to the wind, and this will be very helpful for your doubt sessions and your assignments also, which is provided for the week 2. And before starting the session, I will request you to go through this question. My screen is visible to you all? Does my screen is visible to you all? Comment in chat box.
Okay.
Yes, sir. Yes, sir.
Okay, thank you. Go through this first question, and there are 4 statements are given related to the smart meters, and you have to give that which is true and which is false among these 4 statements. Write in the chat box. Okay. Actually there are multiple correct and multiple false can be there. I request you to go through all the options which is given. Any answers?
B is correct.
B is. Dharmendra is saying that B is correct. I request you to go through all the options. Actually, there are multiple correct and multiple false can be there. Polas is giving A and B is correct. And okay, any other answer? Omar, Narendra, Dharmendra. Akshita, any other answers apart from A and B? Okay, let me explain this question actually. Firstly, here the question is given such that the statements regarding the smart meters. As you see in the right side image, there is an image of this smart meter. I will explain that what is actually it is different from the conventional meters also. Let's go to the first statement. It is saying that smart meters can measure only electricity consumption. Actually, this option is completely wrong, because smart meters can measure the water uses also, water uses apart from the electricity consumption, and also the gas pipeline which you are connected, the gas consumption also it can measure. So first statement actually is false. And the option B, actually it is saying that it provides the instantaneous measurements offering real-time data on the utility consumption. Actually it is correct, because on the utility consumption it can be electricity, it can be water consumption, actually it can be gas consumption also. So second statement is true. And going to the third option, smart meters can capable of measuring water uses in addition to the electricity and gas. Actually it is correct. It can measure the electricity also, it can also measure the gas and gas consumption also, and the water uses also.
Sir, can I
Hi.
speak?
Yeah.
Actually, I thought the smart meter only using the electrical systems. That's why given the B option. Otherwise, C is also correct.
Okay, that's fine, that's fine. In the first view of this question, it can be seen as that it should be electrical consumption meter kind of thing, but actually it is not correct, because anything system you have, if it is convertible to certain electrical system like in the form of current or voltage, then it can be measurable using this energy meter. Coming to the D option, the time it takes for the smart meter to measure and transmit data is typically longer than the traditional meters. Actually it is false, because it takes the less amount of time as compared to this conventional traditional meters. So option A is false, B is correct, C is correct, and the D is false. Here I have given one image of this advanced metering infrastructure based system. Here you can see that in the utility DCCs, that is the data and control center, is at the left side and the consumer is at the right side, and in between there is a communication channel, because if you have certain things and you want to optimize it, suppose you want to optimize your electrical consumption, so you need a communication between the channels, communication between the different components, so that you can optimize the energy consumption between the different elements which you are taking. So here this is the result of answer of the particular question which I have given. And if you, in the right side you can see that smart meter is such that it can measure the voltage, current, phase angle measurement, power factor, watt, VAR, kWh. This is the conventional way. But if you have any water uses capacity, if you want to use it, by converting its flow of water, you can convert in form of certain using certain actuator in the form of the current, that can also measure this flow based energy consumption, water consumption for your unit using this smart meter also. So smart infrastructure is such that it can measure your water, gas consumption, and any other utility which is leading to your money driven kind of system. So this is the second question. Go through it and tell me that which is correct and which is false related to this automated meter reading. Any answers?
Sir, BCD.
BCD. Okay. Dharmendra is giving BCD as a one answer. Any other answer?
BC is the more correct. BC are the more correct, sir.
BC is more correct. Dharmendra is continuously changing its answers. Uh, BC is correct answer according to Dharmendra. Any other answer, guys? Pulash, any answer? B and C. Akshita is giving B and C is the correct answer. Any other? Any other answer? Pulash, Umar, Gomez, Swagat, BCD. Pulash is giving BCD is as a correct answer. Okay, guys. Any other answer? Any other answer from Umar, Swagat? Any other answers? Okay, let's jump to the answer side. Actually, let's read these statements related to this automated meter reading. First, it is saying that AMR enables manual data connection from the utility meter. Actually, this is false. You know that it is automated. Coming to the second part, one of the benefits of the AMR is improved accuracy in the meter reading. Actually, this is correct. Because it is improving the accuracy related to this delay time and also related to this theft also. And coming to the third part, that is the AMR system typically require a constant internet connection for operation. Actually, this is false. It does not require the constant internet connection. I will explain why in the further slides. And coming to the D part, the primary purpose of the AMR is to reduce operational efficiency in the utility companies. Actually, this is false. False in the sense it do not reduce the operational efficiency. It actually increase this operational efficiency because you need more data centers, and for operating it you need the operational time also for that. For the if you are using the communication devices, also your operational time, your human intervention is also there. So operational efficiency should increase. That is no doubt, but it reduces because there is a communication delay also there. The communication data loss also there. In some context you can say that this is true, and in some context you can also say this is ambiguity kind of thing. I will explain why. If you see this first kind of thing, why this is false, that is you need the continuous data connection, because you can transfer that data using the radio frequency also, using the power line communication also. In the PLC you don't need any extra communication setup. You can transmit the data on the same power line. So your internet connectivity cannot be any issue during this power line communication or the cellular networks. Okay, so this is can be said that if you don't have any internet connection also, then the data can be transferred using this PLC systems and radio frequency or cellular networks. Any doubt? Any doubt, guys? Okay. Coming to the D part, the primary purpose of AMR is to enhance the operational efficiency in utility companies, but by automating the meter reading process, the utility can streamline operation, reduce costs associated with the manual reading, and improve overall efficiency in the managing this monitoring energy consumption. In one sense, you can say that this is increasing this operational efficiency of the system, but the operational burden is also coming, operational losses is also coming. In that sense also you can say that some efficiency will go down also, but overall it will increase. Coming to the third question, identify the type of networking for the advanced metering infrastructure. There is one question is given and here are certain smart meters are there. If you see, there are, this is the smart meter, this is the smart meter, this is also a smart meter. These smart meters are connected to some data communication setup centers, and then it is transmitted to some place, and then it is transmitted to the MDMS. So you have to tell me that the which kind of this networking infrastructure is there. Either it is meter connected directly to utility MDMS, or it is vendor proprietary AMI solution, either A or either B. If you know the definition of this basic concept behind this type of networking.
Sir, please once repeat question, sir.
Question is such that that this is a setup. This whole image is a setup of this networking infrastructure. And networking, you know, the networking infrastructure is of two types. First one is the meter connected directly to the utility MDMS. Second is the vendor proprietary AMI solution that is connected to the MDMS. So you have to tell me that either A is correct or either B is correct. Among A and B, which is this setup? At least you try, because from the literal meaning of these options A and B, you can say that this is meter connected directly to the utility MDMS. Akshita is giving A as a correct answer. Any other answer? Pulash is giving B option. If you have read the document related to that given by NPTEL, then you will know that this kind of system very well. Any guesses or any try? Swagat, Gomez, any try? Dharven, any try? Dharven is saying B is the correct answer. Any other answers? Any other answer? Okay, let's come to the answer part. Here you can see that there is a 2A and B kind of system is given. Vendor proprietary AMI solution connected to MDMS. So if you, in the first part, if you see this meter, this smart meter is connected to some communication network, then it is transferred to the DCCs, and then it is transferred to the MDMS. Then it is transferred to the MDMS. In the second part, if you see, this is the neighborhood area network, that is the meter concentrator, and in that case thus multiple sub meters are there, smart meters are there, that is connected to the network neighborhood area network, and that is connected to 1 meter concentrator, and at the end it is connected to some communication network. If you see this communication network, then it is connected to DCC, then MDMS. So in this case, in the second part, if you see, that is the same kind of system which is there in the above part. Actually, there is some issue with the system. Let's wait for 1 minute. 1 minute. Please don't go anywhere. Then my screen is visible. Am I audible?
Yes, sir.
Okay, thank you. Okay, let's go to that question part which I have explained right now. Just okay. Coming to this question which I have told you, I am explaining that this is the first kind of system, that is meter directly connected to this MDMS through a communication network, and in between DCC router as there. And in the second you can see that this is the multiple smart meters were there, which is connected to a neighborhood area network, and it is connected to the meter concentrator, and then it is connected to a communication network. So between the MDMS and your smart meter, there are number of subsystems are there. First one is the NAN. NAN is collecting the all smart meter data, and then it is transferring to this meter concentrator. Meter concentrator is such that it is collecting the whole data, and the saving in is its database, and then it is transferring through this communication network to MDMS. So from seeing this this network, this graph, you can say that this is a kind of system related to this vendor property AMI solution connecting to the MDMS. Why? Because if you see, if there is a there are multiple smart meters are there, and it is connected to a local data management system, that is this NAN network system, that is NAN, and then it is sended to data to a communication network, then it is transferred to this MDMS, then it is transferred to the further processor. So if you see, it is not directly, this smart meter is not directly connected to MDMS through a communication channel. In between there are some networks are also there. So it is the vendor property AMI based solution. How I am saying that, if you see in the market, there are multiple smart meter solutions are there, such that that is optimizing your home based energy consumption. I will give you an example of one EV based system that is very popular. Let me take a new slide for that. Suppose this is your panel. Panel is such that you have a AC bus bar kind of system, that is the AC positive, and this is neutral of a single phase. Then this single phase supply is going to your home, this phase and neutral, to your socket or anywhere. Okay, so if you see that this is the positive, negative, or an earth can be also there, earth can also be there, so for the protection. So if you see, there is a multiple kind of systems are there. So if you connect this system, there is some issue with this system here. Am I audible, guys?
Yes, sir.
Okay, the system is hanging. Through this voice, I am explaining this part. After that, I will restart my system again. If you see in your home panel, there is a AC bus bar are there, that is the AC positive, and AC negative is there, that is the neutral part. And if you connect the home appliances to that particular system, and at that particular time also, if you need this smart meters for this energy consumption monitoring, then if you get some solution from some vendors, they will give you some app also for the monitoring in the real time basis, and they also suggest that how to optimize that solution, how to optimize your energy consumption. Suppose there is a outage in your area, and they will suggest that sorry for the interruption, guys. Let's just start the session. Okay, I hope I have explained the last question. Please try this question, that is the fourth question, related to this communication infrastructure of this smart meters. There are multiple communication networks are given, such as mesh network, Wi-Fi, PLC, and cellular network, and you have to match that with their definitions with respect to the A, B, and C and D. Any answer, guys? First one, Pulas is saying the first one. Any other answer? Any other answer? Dharmendra, any other answer?
The first.
First, okay. First is saying Dharmendra also. Narendra is also saying first. Akshita is also saying first. Let's jump to the answer part. Actually, come to that particular systems which actually you know. What you know actually? You know the Wi-Fi very well. You know the cellular network very well. So let's start with that. Suppose in the cellular network, in the fourth part, if you see if from the A, B, C and D options, if you see the C option that says the utilizes mobile networks to enable communication between the smart meters and central systems, offering wide coverage and scalability. It means that the fourth is connected to the C part. Why? Because it is saying about this mobile networks. Mobile network is what? That is this radio frequency communication, that is cellular network based system. And fourth, it is connected to C. It means that the A first or third option may be correct. And then coming to this PLC communication, initially what I have told, this do not require any communication network. It transmits to the same power line. So communication, if you see the D option, that communication through the existing power lines, enabling data transmission between the meters and utility providers using electrical infrastructure. So it utilizes the same electrical infrastructure for this communication. So third option connected to the D, which is correct. If you see this first and third option, the both are correct. So if you see this Wi-Fi part, what is Wi-Fi? Wi-Fi is a wireless network. Wireless network in what sense? Suppose uh, uh, suppose this first is connected, this wireless communication method that uses the radio signals to connect devices within a localized network, allowing devices to communicate with each other. So devices communicate with each other. Okay, so devices can communicate. If you see that there are multiple smart meters are there that is connected to a Wi-Fi network, and you need that Wi-Fi network data for this optimization of energy. So in that sense, what you will do? And you will do this to collect this all data from the smart meter to the Wi-Fi network, then it transferred to this optimization. It means that it is a localized network at a particular place. It will be placed. And if you see the mesh network, it is actually showing in the question itself that mesh like a structure. So first is A, second is B, third is matlab first is correct. Okay, so this is the answer part. And coming to the next question, this is question related to the reclosers in this smart infrastructure based systems. So there are four options are there. If you have to see that which is correct and which is false. As you can see in the figure also, in the right side there is a one part that is recloser, and it is connected before this feeder on the feeder itself, and one system is connected to this distribution transformer, then to this electronic devices, and then and in parallel fashion it is connected to one switch also. So recloser is connected on the feeder itself before the distribution transformer. So try this question. Plus is saying B and D is correct. Any other answer? Akshita is saying B is correct answer. Any other answer? B means B is the common. It means that one is saying B and D and one is saying B. Any other answers? Omar is saying C is the correct answer. Any other answer? Swagat is saying B. So
B is more correct, sir.
which correct?
B.
B is more correct. It means that the more people favoring B and one person favoring D also and the C also. Let us see that which one is correct. If you see this A part is such that recloser in distribution automation are devices designed to permanently interrupt the flow of electricity in case of fault. That is actually false. Why it is false? If you see in this distribution, this DA network, this distribution automation network, and in the upper part there is a data and control center is there, which actually control this devices using this communication network, and this communication network is connected to the all devices which can be automatically controlled, or it can be controlled through a certain command. So if you see in the B part, it is saying that it is automatically restore power after a moment. In the first part it is saying that designed to permanently interrupt the fault. It is not correct because it actually senses this fault, but it tried to reclose again after a few minutes. Suppose there is a fault and you have to restore after 2 milliseconds. So what this recloser will do, it will sense again this current either decayed or not. If the current is not decayed, it is actually at a level above this circuit breaker, so it will sense that okay, this current is higher than that, so it try to open at that point of time, and after suppose after 4 milliseconds it also again try to close it to restore the supply back, so it does not permanently interrupt this fault. Coming to the B part, the primary function of the recloser is to automatically restore power after a momentary fault or disturbance in the distribution system. That is actually correct, because it will try to restore this momentary fault or disturbance in the distribution system if it senses. Coming to the C part, this recloser can only be operated manually by utility personnel and do not have automated function. That is actually false. It have this automated function. If you see in the right side figure also, it is connected to this communication network itself. Coming to the fourth part, the use of recloser in the distribution automation can contribute to reducing outage duration and improving system reliability. That is correct. Correct in what sense? The use of recloser in the distribution network is such that it contributes to reduce the outage duration. Why? Because this again tries to close this switch recloser and try to make the system again this power flow can be possible in that system. It try to flow the power again, make the system is such that. So improving the system reliability is also one of the feature of this recloser. So B and D option is correct. So B and D option is correct. Any doubt in that? I have given the explanation also, which this PPT will be shared to you after this lecture. Any other doubt? Any doubt? Okay.
Okay, sir.
Okay. Yeah. Okay. Coming to the next part. This is question related to this master stations of the SCADA system. I will explain this what is this master station. Initially you should go with this statements whether which is correct and which is false. SCADA, you know, that is the supervisory control for the remote location control if you have a certain communication between that field devices. Try to read these statements and try to find out which is correct and which is false. False in the sense कि what are the components are there in this SCADA system. whether the all components are there or certain components are there, or and some is not there. A, B, C, D, E. These are the components A, B, C, D, E. If you see the right side image also, you can guess. Pulas is saying all is correct. Any
Sir,
other
all
answer?
are correct, sir. All are
Okay,
correct, sir.
okay. Dharmendra is also saying all are correct. Okay, any other answer? Omar, Kunal, Gomez, any other answer? Omar is also saying all are correct. Okay, let's find out which one is correct, which is false. Uh, First one is saying that one or more data acquisition center servers or front-end processors that interface with the field devices via the communication network. If you see what it is saying, that it is saying that the data acquisition systems are one or can be multiple, and that front-end processor or front-end processor that interfaces with the field devices, that interfaces with these field devices. If you see in the right side image also, if you can see that this field devices is connected to some communication system, this data acquisition server. It can be multiple, it can be multiple for suppose there are remote location, there are 3 plant and you want to control all, so data acquisition system will be other for different systems, and it is communicated with these field devices. And coming to the B part, there is real-time data server that contain real-time database. Actually this SCADA is such that it will monitor and control in the real time itself, so that is correct. So that is correct, because you need the real-time database for this real-time operation. And the historical server is also there. Actually it is also there, but it is not permanent. Actually what I mean to say that the historical server will be there that maintain the historical database, but for maintaining the, suppose you want to maintain for a 1 year data, so for that region you need a large database server, large historical server. So what the power plant will do, power plant take the data for the 2 month, erase it, and again they take the 2 month data. It means that if they are taking the day ahead data, it means that before 1 month or 2 month data that will be erased if the solution got resolved. So coming to the D part, that is application server that runs various EMS application. That is also correct. Why? Because you need the energy management system application devices also, various EMS devices. And coming to the D part, that is the operator workstation with human machine interface, that is also you need, no. But why? Because you want to control this human intervention is there, and you want to control your power plant remotely. So you on the SCADA, that is there the system, that is the human machine interface. After that you see, if you give the command, then SCADA will sense it and it will transfer through the communication channel to the field devices. In the lower part I have given one image. This image is related to the smart meter. Smart meter in such that this is a signal acquisition. The first section is the signal acquisition. Why is it is signal acquisition? Because it connects this analog data through the physical environment. So signal acquisition, what will do, it will sense and collect the data based on this what is happening in the physical environment. Then there is a signal conditioning. Why signal conditioning? Because this data you have collected have a noise, high frequency noise, low frequency noise, or low energy signal. So you need to condition that data to a level, that is power level or current level, so that you can transfer it and reduce the noise also. So there are 8 HC converters are there. So this analog data which have a certain current level, up to that which is data can be convertible using this analog to digital converter. Then there is a computation based system, and then computation can be done, and suppose you have taken this current data and voltage data, computation will sense and convert in the form of kilowatt hour using this power factor and other digital captured data. So then it is communicated to this through this communication channel to the user or any other utility customers or OEMs which have provided these services. So coming to this solar PV system, that is actually a very important topic for your assignment purposes also. Before jumping to this solar PV system, I want to know that is there any doubt related to the sections which I have covered before? Any doubt? You can write in the chat box if you have no doubt, no or yes, or doubt. You can open your mic also and tell me that. Do you have any doubt related to this smart metering infrastructure based questions or anything?
Sir, once again explain block diagram.
Which question, Akshita?
Last question, block diagram.
Okay. So let me explain the last question.
One my sir query is
Yeah.
just differentiate between the reclosure and circuit breaker, because some functions are related common of the reclosure and circuit breakers.
Okay.
Some functions, right? What are the differences and how can differentiate?
Okay. Let me explain the first Akshita questions, and after that I will jump to your question. And if you see this, I have explained this SCADA based system. Let me remove this. So in the last question, what I have explained this, that if you see this image, the typical modern EMS infrastructure, there are in the upper part there are certain field devices. Field devices are there which is communicated through the dash system. Dash system is such that it collects the data, acquires, and then it is transferred to this servers. Servers such that real time servers, historical data servers, or application based server, or the operator workstation. So field devices, you are communicating your data is, suppose there is a steam power plant is there, and you want to control the valve of the steam using this SCADA system remotely. So what you will capture the data of this valve, when to on this valve or when to off this valve. Okay, so that is the field devices which collect this data, this when to on, when to off, and the particular present situation of this valve. Then it is transferred to this communication network to the data acquisition server. Why? Because if the communication network is of use length, then it can be data loss can be between them. So it is specified to a certain power level. So after that, it can be converted into the this digital form or any data related system. So it is transferred to the various. This is real time database server which is save this data. Then the historical data server which save data for the historical uses. After the completion of this valve related problem, there is a application server is also there. Application server is such that which actually sense the certain control system or control algorithm is there, control algorithm which sense this what is the present situation, and this control algorithm will give this command to this operator workstation will give this command to this on the application server. Then it's communicated to this field devices. Then the valve will open or close in that sense, on or off. So there is a multiple channels are there if you are controlling this field devices through your workstation or operator workstation. So So you have to go through a various channel, then you have to come to a particular solution between this SCADA system. So coming to this problem related to reclosure in the circuit breaker. That problem is okay. If you see this recloser, what you mean by this recloser? Recloser in the sense कि why it is different from this CBs, circuit breakers. Okay. So circuit breakers are currently two types in the market. One which is manually operated, which sense the current that I is greater than the I nominal and it will trip. Okay, relay will sense and give the command to CB to trip. And one automatic is also there. Automatic in the sense in that if it is off, got off using this checking the nominal current based system, then it will again become on by self after sensing that this is the current is again came back to the this less than or less than nominal current or less than to certain factor of this nominal current. So this is CBs which are actually manual or automatic. What about these auto reclosers? Auto reclosers are such that suppose this is similar to this automatic kind of system which try to reclose again after this fault is cleared, or if a fault is permanent, then it will again open this switch and it try to close again. After that, after few minutes it will try to close. Okay, auto reclosure in one sense like this only. And one more feature is such that if you want if you are certain maintenance is going of this transmission line, is this feeder. Okay, so at that particular time you have to de-energize the energy which is already been there in this transmission line. So what you will do, there is a switch also in the lower section also. So in that particular time you close this switch, you close the switch during this and open this feeder connection. So after removing this, opening this system, you can maintain the line before that, before of this, and this switch is getting on. Switch is getting on, it means that the extra energy which is being there in the system, it is gone to the ground, it is connected to this switch. So what is the use of this recloser? In one sense, that is the automatic CB kind of system, and in the second sense it is for the during the maintenance of this feeder wire also it is come into one picture. So there are two advantages of this. Dharmen, this is fine, or I will explain further?
Yes sir, yes sir.
Okay. Coming to this solar PV system, that is photovoltaic system, before jumping to the question part, let's explain this these theories. Theories in what sense? If you see this figure and this figure description, it is saying that light incident on the cell create the electron hole pairs which are separated by a potential barrier and creating a voltage that drives a current through an external circuit. Let me explain this how it works. Suppose there is a p-n junction is there, this is the p side and this is n side, and in between you have this depletion layer and you have the certain carrier, this ions are there in between, and these are carriers, positive or negative carriers. So when light incidence on this p-n junction, it is completely isolated, there is no physical contact to get this energy. So I am considering this first situation that it is under the open circuited condition. So when the light falls on this system, so there is a two kind of this band is there, one is the valence band and one is the conduction band. This is the valence band and this is the conduction band. When the energy, this energy falls on this this valence band, the electrons and holes which are there into this system got created, and this electron jumped to the conduction band and it started to flow. Suppose I take the three cases. First, when this p side is such that this holes are in this majority, and these electrons are in minority carriers. So when the light falls on it, what it will generate? It will generate the whole electrons, but during this due to these holes are there itself present, it got recombined. Recombination will happen. Why? Because the majority carriers are there. Majority carriers are what? Holes. And what is the minority carriers? Minority carriers are electrons. So few electrons are generated that gives absorbed by this hole. So there is a, if you see the equivalent system, there is a net hole kind of system is there. So same, if you take the same situation in the n side, if the light falls, the electrons are get created and certain holes are there. If the electrons are created, this electrons are in majority and the holes are. So this few electrons which is created due to this light get recombined with these holes, and it can be possibility that net electron can be a possibility. Possibility can, it is a mostly can be there. So taking the third situation, if it is fall to this depletion layer, falling to this depletion layer, there is certain barrier is there, and this is p, it means that it is a negative ions and it is connected to n, so it is positive. So if the electron or holes are created here in between this depletion layer, so in the right side, in the n side, this electron is in majority. In the left side, the p side, it is positive ions. These holes are in majority. So this hole which is created inside this system get drifted. Why? Because due to this ionic charge. Ionic charge is such that this hole will be repelled by this system, and it will drift towards the p side, and same with this electron, it will drift to the n side. So what do you mean by that? It means that in the p-n junction, net p will increase on the left side and net e will increase on the right side. So whatever the amount of there in the majority carrier device, majority carrier side, that will increase. What do you mean by that? Here it is a positive kind of system, so net positive will increase, and in the right side net negative will increase. So there is a potential kind of system will happen in between this p-n junction. So but there is a no path to travel this electron or the hole, so net positive will keep on increasing to some extent, and same with this negative ions, it will keep on increasing to a certain extent. Suppose through a electrical contact, you develop a electrical contact and connected a bulb in between this p-n junction. So what will happen? This electron will try to move from this side to this whole side for the recombination, because there is a path through this lamp. So what will happen to the current? Current will move from the opposite side, which will make this bulb to glow. This is known as this photovoltaic effect. How photovoltaic? Because the light falls on the system and the p and n carriers are generated. After that, this whole system keep on developing this minority or majority carrier system, and the current will flow. Okay, is it clear to everybody? Any doubt in this? Is it, sir, in the signal condition which is applies to signals a low pass or high filter? It is low pass filter. I will explain further why I am saying low pass filter. Is there any doubt in this this working of this solar photovoltaic or the photovoltaic effect? Any doubt related to this minority or majority carrier generation? So what I have explained right now, that if there is a p-n junction and there is a potential barrier, this is a p side or n side, and you connect a load, then the current will flow. Okay, and in the second point, what I am going to say, that this how this voltage will be generated up to what amount, and what amount this current will be developed. Suppose I will take a one system, this is same p-n junction diode, and I have, this is the negative side, negative ions will be there here, and this is positive ions will be there. Suppose I am not connecting anything to this electrical connection. So what will happen, this P will keep on increasing, P will keep on increasing, and N will keep on increasing in the N side, and after that what will happen, this P will come to this, near to this depletion layer itself. After that what will happen, this hole was drifting towards this P side, no, so this P will repel this hole. What will happen, this P will come back itself in this potential, this depletion layer itself. What will happen to the electron when it will move to the N side? If it is keep on increasing, then it will repel this electron itself. So this generation, this holes and electron will recombination will happen, and this will, during the recombination, the extra energy which is coming to this through this light, it will again got emitted, and the electron will move from this valence band to again to this conduction band to again to the valence band. So what happened to that? It means that a certain potential will be developed. After that there will be no potential increase will be there. So if we draw a curve in the sense, if this is a IV curve, so if we keep on increasing this potential, so a limit will come, that we say as a VSC, V short circuit, sorry, V open circuit, because it is in open circuit condition. So at a certain potential will come, after that there will be no potential increase. Why? Because the recombination is happening. So if we take the third case in the sense, if we same the p-n junction and connect a load, connection of load means that this electron will keep on moving towards the P, and this P will again move towards the. What happens with we do not connect, we connect a resistor which are zero resistor. It means that short circuited condition. It means that the all electrons which was there in the N side, which all will go towards the P side at a once. So at that condition what will happen, the current will be very high during this short circuited condition. And if the all electrons and holes are getting recombined, after the recombination there will be no electron and no holes in this layer. After that no current will increase. So it means that there is a certain threshold of current will be there. Why I am showing in the negative direction? Because the current is in opposite direction to this electron. So the negative ISC, it will not develop the current above this. So how this IV characteristic in between will happen? If you increase the resistance in between, suppose you have taken a low resistance, then increases, then potential keep on increasing, the potential will keep on increasing, and it will come to this VOC layer. So how this IV characteristic you will get like this. This I max is negative of this ISC, which generally we encounter, and this IV characteristic you will get in this fashion. Here you can see this is the V max, that is the open circuit voltage, and there is a short circuit current, that is the ISC. Above this you cannot develop this current, and above this voltage level you cannot, the voltage buildup can happen. So there is a threshold between the VSC and ISC. So let me tell you one thing, that Suppose in the short circuited condition, if I am saying in a short circuited condition, it means that there is a wire connecting to the P and N side with a zero resistance. If we try to increase this bar in the sense ki length of P side and length of N side, what it means that because the light coming to this PN junction, this P side will again getting increased. It is more than what actually was there initially. What I mean to say, that the length of P side, this is initial, and the length of N side, it was there initial. After that I have increased LP dash to Ln dash, length got increased. So the recombination, it means that the minority carriers on the N side, majority carrier on the N side will increase, and also in the P side. It means that the current will also increase in that sense. So by increasing this length of P and N side, you can increase the current, and by increasing the light also, because it is not by increasing the illuminance, you can increase this current at certain ISC level, but you cannot increase the above level because the length will become lower. Length will reach to a threshold limit. Okay, is there any doubt in between? Any doubt? Dharmen or Akshita, any doubt?
No, sir. Thank you.
Okay.
No, it's clear.
Okay.
Just
Thank
a
you.
question.
Yeah.
So from you also mentioned that from conductance band it also moves to valence band. Does that helps the developing like the LED technology is like that only, right?
Yeah. Same principle. Because the photodiodes are working in the same principle, but only since that it is the battery which is connected in between this P and N side, it is in the reverse bias direction, because what we are doing, we are connecting in the forward direction. Okay. So that is the basic main principle of the photodiode, that it is a reverse bias kind of thing. So coming to this curve, that is the what we get from this minority and majority carrier, that is the VSC and ISC. If you see this at a particular point, that is the maximum power point. Maximum power point is there. This is this arrow. If you see at that particular point, if you project it on the x-axis, you will get a point that is VMP, and project on the on the x-axis, and if you are projecting in the y-axis, you will get a point that is IMP. If you multiply this point, that is the VMP and IMP, then this area will come. This is the PV curve. This is the maximum power which can be generated, that is the VMIM. And coming to the one concept, that is the fill factor. Fill factor is such that if you are connecting this ISC, project it to a particular point ISC, and project a x-axis point from the VOC which is parallel to y-axis, and you will get a point that is called as a Pmax. What is Pmax? Pmax is such that is multiply of the VSC and ISC, and what physical maximum you can generate, that is the VMIMP. So this fill factor give a concept that is the VMIM is the Pmax which can be generated, and VOC and ISC which could be generated, and this ratio is fill factor. We have one question also, after that we can understand that also. And coming to the certain equations, that is the I is equal to, if you see that what is the diode equation, that equation is such that I naught e to the power Vd divided by neta Vt minus 1. If you see, this is the similar expression that is of the diode, because it is also a similar PN junction diode itself, no? After the recombination and all, this is this is a solar cell, and if you reverse bias it, it will become the photodiode. It will emit after absorption. So this I naught is the reverse saturation current. Reverse saturation current is such that when this minority carrier, suppose this minority carrier will flow from this n side to the p side or p side to the n side during this when the current is increasing. That is the reverse saturation current, and it depend upon the length. Length in what sense? Suppose, let me explain. One sense. Suppose this is the p side wafer, p side wafer, and it have what it will have? It have holes in the minority sense. And suppose I am injecting electron in it, injecting continuously electron. So what will happen initially? It will get recombined with this hole, then with this hole, with this hole, with this hole. After that, what will happen? If you inject the more electron, this will recombine with this, with this, with this. This is the depletion layer. So after that, it will come to a certain boundary. When you stop injecting the electron, then it will come to a point where it stop this recombination. That length is known as this recombination length. This is ln, lp of the p side during the n injection. So after that, it will not go further. So what do you mean by that? It means that if you this injection, the recombination happening, it will lower down this concentration, lower down the concentration with the fraction that Pn is equal to Pn naught e to the power minus T by Tp, L by Lp. Lp is this length, is coming to this Lp length. We are not going into depth of that. I will simply explaining this. What is this Ln? And Na is this acceptor ions, and Nd is the donor ions, and Ni is the concentration from the you note that during the combination, that is the NaNd. NaNd is equal to Ni square. From that it came. So what will be the I total? I total will be such that if you see compare with the normal p injection, if you see the normal p injection, what will be the IV characteristic of that? IV characteristic of normal diode is such that like this. But the what we are getting like this. We are getting like this. It means that it is shifted below certain level, because during this is of the p injection diode, and this is of this solar cell. So what with this current equation, I is equal to I naught e to the power Vd divided by neta Vt minus 1, and below what will be the equation? It will be I naught e to the power Vt neta Vt minus 1 minus certain ISC, below which it is below this p injection diode. So this factor came from this equation, that it is below the p injection diode. That what amount? This is IL, that is ISC. So how you find this VOC equation? VOC equation is such that in this equation itself, make it to 0, because in the open circuited condition the current is 0. So after that you the current is 0. In that find out this V is same as this VOC. So what we learned? We learned this equation of the PN diode, P injection diode. Second, the reverse saturation current. Third, how this equation of total will come, and the fourth, the VOC equation and the field factor equation. This is the most important. Why? Because in the understanding point of view, that how this IL will come, how this Vd came, how this T temperature variation is there, that is very, very important, and how this fill factor equation has been derived, that is very, very important. Is there any doubt? Fill factor, Kunal Soni asking that the fill factor should be close to 1. That's right. That's absolutely right. Why? Because we want to generate this power to a level of this P max. Why? Because we are in the open circuited condition, we are getting this VOC. In the short circuit condition, we are getting ISC. So why we should not generate this to a level of P max when we have this solution of this VOC and I max? So research is in this direction itself, to how to reduce this fill factor, to how to make this fill factor to close to 1. Okay. Is there any other doubt?
So during quality inspections, we should ensure that So FF is one of the parameters to make ensure the quality of
Yeah,
a panel.
yeah. It can be a one of the parameter to check whether the your panel or the panel you have generated or made, it is of a certain level or not. I have one question also which shows this efficiency and the fill factor. In that we will explain, I will explain the further this fill factor. Okay, is there any other doubt, Dharmen? Is there any other doubt?
No, sir. Thank
Okay.
you.
Okay, let's come to this equivalent circuit of the solar panel. What I am said that this is the equation of this I is such that this I naught e to the power Vd divided by neta Vt minus 1 minus IL. Why? Because it is lower to this p-n junction diode. So same equation is written here also. Why? In the negative fashion, because we have seen that the I have made this, why ISC is below this 0 axis, this x-axis, we made intentionally to above this ISC. So this is coming as a positive, IL is coming positive. So this is the equivalent circuit of this solar PV cell. You can see this is a constant current device. Constant current device in what sense? Because it is generating a constant current when the certain fixed amount of illumination is implemented on that. And there is a one diode connected here also depicting that it is similar to this PN junction diode in this and one RSH is and RS is also there. This is depicting the losses, which we will see in the further slide what kind of losses will be there in the PV panel. So basic funda was that this is the equation, and how to write this, this is the equivalent circuit, from where it is derived, from this equivalent circuit. And I depicting this output current, IL is the photo generated current because it is lower than this PN junction diode. ID is the diode current that is similar to this PN junction diode. SS is the shunt current which is going into this RSH, and neta is the diode ideality factor, that is 1 for the silicon and 2 for the germanium. And the Vt is 0.059 at a 25 degrees Celsius. It is variable, because Vt is the Kt by Q, and it depend upon the temperature and the Q itself. What is Q? Q is the electronic charge. And here I have given this certain parameters and their physical meaning, what they are depicting. So if you see that this is the green boxes, 2 green boxes I have kept depicting this RSH and RS, this series and shunt. What about this shunt resistance? It signifies this power loss caused by the presence of shunt resistance are typically due to the manufacturing defect rather than poor solar cell design. Okay, and what RSC defining? This is the movement of the current through the emitter and the base of this solar cell, and the contact resistance between the metal contact and the silicon wafer, and the resistance of the top and rear metal contact, that is the P and N lower side. And the main impact of this series resistance is to it reduces the fill factor. So if you reduce this this RSE, so you will get the same voltage which is you are getting at this shunt point, shunt resistance point, which it will be same as this V if you reduce this RS. So that is very important to reduce this RS. High values also reduce this short circuit current excessively. You cannot reduce this further. If you further reduce to a certain optimal level, then it will also reduce this short circuit current also. Okay, is there any doubt? Any doubt related to this equivalent circuit? Okay, so no doubt. So then we will moving to this further slide, that is the generation of the solar cell. We have questions also that but the theory part is also, this is new concept, that you must have to understand that how this parameter, what the parameter is saying and how it has been derived. So this is the first generation solar PV, that is the crystalline silicon solar cells, And this advantages of this that it have the higher mobility, mature technology, but disadvantage is costly and the loss of photon energy. Then we jump to the second generation thin film based solar cell. Thin film based solar cell, it have amorphous silicon, copper, indium, gallium selenide, and the cadmium telluride, and less expensive, but it also have the lower efficiency, will be less than the 5% 6%. Coming to the third generation emerging PV, that is a perovskite solar. It is in development phase because perovskite has not been commercialized yet. It is also not manufactured yet. It is a lab driven solar cell right now currently. And one more, this is the organic solar cell which can be disposed, because there is a problem of disposing also is there with the solar panels, where to dispose and how to dispose and how to recycle it. And one more is the dye synthesized solar cell, and the advanced concept are there. So there is a big funda is such that this is the first generation, second generation, and third generation. And the first generation is basic normal silicon PV based cell, and second is the thin film based cells, and third generation is the emerging. Here I have shown one question. Before jumping to the question, I have given one image, right side image of a two panels. In this, one is the monocrystalline and one is the polycrystalline. You have to tell me that which is monocrystalline and which is polycrystalline by observing this panel itself. Anyone can observe that? Anyone can give answer, opening mic or anything.
Second is correct.
Second is polycrystalline, right, Dharmin?
No, what I'm saying, second option is correct.
I am asking different this question. We will go to this question. To you are saying this second. I am asking that this right side image, there is a two images are there. Two images. One is
sorry.
Oh.
Yes.
Okay.
okay. Sorry.
One is the monocrystalline and one is the polycrystalline. You have to tell me that from these two, which one is the monocrystalline and which is the polycrystalline by observing the panel itself. Any guesses? Check the dimension, the configuration, the image, how these are different.
Black one is monocrystalline.
Left side is monocrystalline. Black.
How to recognize, sir?
That is the good thing. You are not recognized, but there is a trick that you can say that this is polycrystalline or this is monocrystalline. First one, okay. Let's coming to the answer side. If you see in the center part, if you see the center part, first one is it is a square kind of thing, and if you see the right side image, it is a kind of diamond shape. No, so there is a physical difference between this polycrystalline and the monocrystalline. First one is the monocrystalline, and second one is the polycrystalline. Black one is the polycrystalline. And how you say this polycrystalline? By observing this diamond shape in between this. If you observe this is diamond shape, it is polycrystalline. If you square shape kind of shape, then you can say that this is a monocrystalline cell. Okay.
So on the basis of shape only we can classify it.
No, this is a kind of recognition, means how to this first glance how you say that this is a polycrystalline or monocrystalline without observing any difference in between the power level or anything. Okay. Try this question. Dharmendra given initially that the second option is correct. Any other answer of this? Okay, Akshita is also saying the first option is correct. Any other answer? Akshita is saying the first and Dharmendra is saying the second option. Any other answer? Gomez? Ansuman? Any other answers? Okay, let's jump to this answer side. This B option is correct. Why? Because the monocrystalline, I have shown this the image that of the monocrystalline and the polycrystalline, and this monocrystalline have above efficiency as compared to the polycrystalline, but polycrystalline also have certain advantage over monocrystalline that you have to search. And this is actually the crystalline based wafer base, that if you see this PV cell types, it comes under the crystalline silicon wafer based, and this is of two types, that is polycrystalline and the monocrystalline, and the monocrystalline have higher efficiency as compared to this polycrystalline. And coming to this thin film based technology, that have this amorphous tandem based and this gallium selenide and cadmium telluride. In also that the copper, that is the indium gallium selenide, that is having the higher efficiency as compared to this cadmium telluride. And at the last, that amorphous silicon have the lowest efficiency of this 5 to 7%. Okay. Then coming to the next part, this is the certain statements are given, 5 statements are there. You have to find out that which is correct and which is false. Okay, plus you are also correct, that is second option. Try this 8th question. Any other answers? Any other student? I want the answer from the everybody, no? Because this is an interactive session will be there. If you have any doubt, you can open your mic and ask me. Any doubt? Swaroop, please try this 8th question and try to give this answer.
Two, three, four, five are correct.
2, 3, 4, 5 are correct according to Dharmendra. Any other answers? Pulash, Akshita, Gabriel, Anshuman, Narendra. Any other answers? Akshita is giving 2 and 3 by Akshita. Any other answers? Gomez is giving 1, 2, 4, 5. Okay, 1, 2, 4, 5 Gomez. Any other answers? Okay, let me come to the solution part. First, let's see the first question. It's saying that solar PV can be used for either centralized or distributed power generation, and it requires less surface area. First will be false. Why? Because it requires a large surface area. Larger surface area to capture the larger amount of this solar light, but it is centralized, it can be centralized or distributed, but it requires the larger surface area. So first option is false. Coming to the second part, the light, which is a pure energy, enter the PV channel and impart enough energy to some electron, that is negatively charged atom particle, to free them. That is correct. Why? Because we are giving the energy, that is in form of light, to this p-n junction diode, and after this electron become free and it moves from this valence band to the conduction band, and it moves if there is a physical connection between the p and n junction. Coming to the third part, that is the photo voltage. It is a built-in voltage barrier in the cells act on this electron to produce a voltage which can be used to drive a current through a circuit. That is true. Why? Because if we have seen that now P should increase, N should increase during when the light falls, because it is a positive carrier, and this is a more positive and more negative, so the voltage will be developed. And if you have okay, am I audible?
Yes, sir.
Okay, let's come to the next question, that is the types of solar PV system. First one is the grid connected solar PV system, and second one is the off-grid solar PV system. In this grid connected solar PV system, if you see, this sunlight when falls to this solar panel, it will generate a DC voltage, and using some DC to DC converter, it is transferred to this inverter. Then inverter convert this DC energy to AC, and it is used for the electricity consumption in the house also, and to the utility grid also. It is sent to the utility grid also. In the second, this is the off-grid solar PV system. If you see, there is a no grid in between, so this solar PV will generate DC power, and it is connected to the charge controller also. Charge controller, through charge controller, it is connected to a certain battery, and this battery is connected to inverter, and then it is fed to the home. And this inverter can also have this operational generator also when the solar PV is not in if the irradiance is very low, and it cannot generate the energy which is being required. So what is the main difference between them? First one is the electricity utility grid. It is connected to utility grid, but the off grid is not connected. And second is this charge controller. Charge controller, what is the use of charge controller? It distributes this energy to maintain this battery bank voltage level at a constant level. That is also needed, no? If you are connecting a certain DC voltages battery banks, so the voltage level of that battery bank should be maintained by distributing the equal amount of energy in between them. That is the main basic concept. So we have one example related to this solar charge controller, that is question, and you have to tell me that which is correct for this solar charge controller and which is incorrect. Please try this.
All are correct except 6.
Dharmendra is saying all are correct except 6. Any other answers? Pulas is saying 1 to 5 is correct. Okay. Any other answer? Akshita? Swaroop? Narendra is saying 1, 2, 3, 4, 5, or and accept 6. Pulas is saying 6. Okay, let's jump to the answer part. It is actually if you see the all 6 options, it is all 6 options are correct. How I am saying that? First option, that is it prevent the battery overcharge. Actually, it is correct. The main concept behind this charge controller itself is that it should control and maintain the voltage at a constant level by distributing the charges or by dissipating the charges. What I mean by dissipating charges, if you have the extra charges, you should dissipate in form of I square R loss, or you can transfer this to a certain battery which have a lower charge level battery, so that it can come to a level which is at a constant level of voltage, and it blocks the reverse current. That is also true. It also block the reverse current if it maintains the same DC voltage. So there is if the voltage is constant at a side, at all point, there will be no current will flow in from the one side to the other side. Okay. It prevent the over discharge from the battery. It also prevent. Why? Because if you have to maintain that SOC level. Why? Because 20% to certain 50%, if there is a lead acid battery and you also have to maintain this 20% to 70 or 80% for this lithium ion battery. That is also needed for the SOC control. And prevent the electrical overload, that is also correct. Why? Because it is also not dissipating at a once, because it have a certain time constant to flow. If it is a millisecond, it will not respond to the fault which is came just now. It will take 1 minute millisecond of time, then respond to the this overload condition, and if it is a current which is greater than it can supply, it will trip. It also display battery status, that is also correct, and it also maintain the DC link voltage, that is also correct. Why? If you see this charge controller from the image itself, if you see this charge controller, it is connected to the battery, and this battery is what? It is connected to a DC bus bar, and this DC bus bar is connected to this inverter, from which the DC to AC conversion is happening. So for maintaining this 230 volt and 50 hertz supply, maintaining this amount of voltage level, you need a constant DC voltage level at a DC link. Okay, so for maintaining this DC link voltage also, it dissipates this battery power to the DC link, so that it can maintain the voltage which is required to generate 230 volt. That is also required using this charge controller, solar charge controller, to maintain the DC link voltage for generation of exact 230 volt and 50 hertz supply from this DC system. Coming to this losses part, there are multiple losses in the solar panel, that is the fundamental losses and the technical losses. You can define this fundamental losses as low energy photons, excess energy of photons, voltage loss, and fill factor loss. And the technical losses are then optical and electrical. Optical in terms of reflection, shadowing, non-absorb, because if the certain amount of ray is coming to a certain surface, some will reflect, some will absorb, and some will some will reflect and some will be absorbed. That is also one kind of technical loss. And in electrical losses, that is the ohming losses, which I have shown you, that is the RSC and RSH, and some of the recombination losses also there, when the electron and holes got recombined and releases this energy to and come back from this valence conduction band to again to the valence band. These all are the losses in the solar PV system. Coming to the effect on this solar PV characteristic. If you see, first is the effect of solar irradiance on the IV characteristic at a constant temperature. If you see the red color, this is the 1000 watt per meter square, and second one is the 750 watt per meter square. So the current level at a 1000 irradiance is higher as compared to this 750 level current. So what you will infer from that if you increase the this irradiance, the current ISC will increase. First observation. What will be the second observation? Second observation, it is that it is at a constant temperature. No? If you see this Pmax which is generated using this Vm and Im is also getting down as the irradiance will down. So there are two observations of that. ISC is also proportional to this irradiance, and Pmax which is generated is also proportional to this irradiance at a constant temperature. And there is a very slight difference deviation in the VOC. If you see, there is a VOC changes very slow during the irradiance change. So VOC is nearly constant when you change the irradiance at a constant temperature. In the right side figure, this is the solar irradiance variation with the PV characteristic. If you see, this is the P max, this is the P versus V characteristic. This V changes very low during the change of irradiance, which I have shown you in the left figure, and this P max changes when the irradiance got changed. So The main crux of this two figures are such that the irradiance affect this ISC, but very less effect on the VOC, and it also affect the Pmax. Coming to the next figure, if you see, this is the variation at a variable temperature. Okay, variable temperature. If you see the ISC changes very low during this variable temperature, but VOC changes very high. This is the curve. If you see this, if you go from 50 degree to 25 to 0 degree, your V will increase. VOC will increase if the temperature decreases, and your ISC will nearly constant, and the Pmax also nearly constant. If you see, and in the right side, if you see this output power versus terminal voltage, by varying this terminal voltage, if you see, this power is also variable but not very high, but it varies. Pmax also vary during the variation of this temperature, and ISC remains nearly constant, and VOC is very high during the variation of this irradiance, during the variation of temperature at a constant irradiation. This is wrong. This is the effect of temperature at a constant irradiance. This is wrongly written. And coming to the last part in the sense that PV curves are there, two solar irradiance and two temperatures are given. If you see this, the red figure and the blue figure, that is same observation, no? Red figure and the blue figure at a different temperatures at a constant irradiance. Constant irradiance, this constant irradiance. If you see, this VOC got increased. Because of that, this Pmax got increased, but the ISC will be nearly constant in this case. If you observe this red and yellow curve, this red color and yellow curve, there is a less deviation in the VOC. Why? There is a deviation but less deviation, because the temperature change is not very high. If you see the red color and the purple color, this curve, this purple color and the red color, here the VOC changes very low, but the ISC will be high. Why? Because the constant temperature irradiance got changed from 1000 to 400. Okay, so main crux of such that, if you see this figure, that irradiance changes, this VOC remains nearly constant, and ISC changes very high, and the Pmax changes. And this, if you increase the temperature, the VOC will decrease, main crux, and the Pmax increases very slightly. Main crux of this question. So try to solve this question, this 10th question. This is related to the fill factor and the efficiency. Fill factor and efficiency. Any answers? Any part you can try, any part, first or second. Any answers, guys? How many of you trying?
Yes, sir, I am trying, but
Okay, okay.
I think some mistakes happening by
O-
me.
Okay, let me explain. Let me explain, guys. See here. What it is saying that the fill factor of the photovoltaic module is 0.8. 0.8 is the fill factor. It is given. That is, the fill factor is equal to 0.8, and the solar cell illuminated uniformly with the solar light power of this. It means that E radiance is such that this is a 100 milliwatt per meter square, and the area is given such that area is equal to 3 centimeter square. This is here some mistake is there. This is centimeter square, sorry for this is the centimeter square. And a single cell module has a open circuit voltage, that is the open circuit voltage is equal to 0.6, and ISC, then the short circuit current is 8 amps, and the module have this 48 cells, and the voltage at the maximum power is Vm is 0.9 times of this VOC. So first coming to this current at a maximum. So what is the equation of this fill factor? That is the Vm Im divided by VOC and ISC. Okay. So fill factor is given as 0.8, and the Vm, what is the Vm? Vm is 0.9 times of VOC. That is the VOC. And what is Im? Im is given. Im is not given actually, but you can find out using this power.
Yes, yes.
Yeah, you by using this irradiance you can say that this power which is generated maximum, that is the 100 milliwatt multiplied by 3, that is the 300 milliwatt. That is same with this Vm and Im. You can place here also, that is by calculating this Im from here, that is the 300 MV divided by this Vm, which is given 0.9 times of VOC, which is 0.9 multiplied by 0.6. By putting this Im value and this ISC, which is already given 8, you can find out this Im current. It will come nearly up to 7.11 amps. And how you find this efficiency? Efficiency is such that what could be generated, that is the VSC and ISC, and what have generated, that is the VMIM, is the efficiency. And VMIM you have this 300 milliwatt, and you can put this VSC value. Okay, let's finish this session with few slides. After the few slides, so am I audible? Somebody please answer. Am I audible?
Yes, sir.
Yes, you're
Okay.
audible.
Okay. Coming to this construction part of this wind turbine, basic 3 slides are there. This construction of the wind slide says that there is a multiple in between systems are there, such as this rotor, this wind fins and windmill fins are there, and then this is the rotor kind of say, the rotor is there. Then the low speed shaft will be there, which is connected to this gearbox to adjust the speed. Then it is connected to the generator terminal, then to a controller which control this power flow, and the anemometer for the checking the direction. And in between there is a yaw drive. Yaw drive is for that, it is for adjusting the orientation of the entire turbine such that the rotor is always aligned with the direction of the wind. This is the basic points which I have, and there is a knuckle also there. Knuckle is this system which is for generating this electricity, and how this housing structure which have this electrical power generation capability, and it is then to transfer to the utility grid. And this is the basic diagram. And coming to the main important point is that is the wind power. What is the expression of this wind power? That is the half rho a v square v cube, and multiplied by one more factor is there, that is Cp. Cp is the Cp I will explain for with this diagram. That is the Cp is the function of this theta. Theta is such that this is the, suppose this is the your blade, and this is the rotor axis. This is plane of rotation. If you take the center of this blade and make a line, this angle is known as theta, and this wind direction and this theta angle in this center axis of this blade is known as this beta. Okay, and this Cp is the function of this lambda and theta. I will explain lambda. Lambda is the tip speed, and theta is this angle, and it is a non-linear function. And there is a law, that is the Bed's law. It says that if you can produce only 59.3% of energy, that is with this rotor kind of dynamic system, but you cannot produce this 100%. The remaining 40.7 will be wind energy must pass through the turbine without being harnessed. This law says that it means that the 59.3 will be captured, but this 40.7 will be lost. Why? Because this wind energy must pass through this turbine without being harnessed. In the right side graph you can say this statement also. If you increase this lambda, this speed ratio, you can say that at a certain point, that is a Cp max, if you increase this lambda, you cannot get this Cp max at a other this lambda value. It means that at a certain point, this lambda, this speed ratio, you will get a certain point, that is Cp max, and at that particular point there is a Vpw, that a wind power which is generated is maximum, and it is only the energy which is generated is 59.3% only what is actually being coming. There is this question is there, this wind power versus wind speed there, and this curve is wind power versus wind speed, and this line is the rated power condition, rated power at a particular wind speed, and there is a ABC terms are there. You have to define that, you have to search from this option that what ABC define, that is a cut-in speed, rated speed, or cut-off speed. Due to the lack of time, let me explain this only, because there is a time issue is there. Already we exceeded this 530 limit. So there is a three kinds of speed is there with this power versus wind speed, that is the cut-in speed, rated speed, and the cut-off speed. Cut-in speed is such that below which the turbine will not produce power. This is the cut-in speed, below which there is a no power generation, and the rated speed at which the rated power is generated, which is this value. at which this rated power is generated. Rated power in what sense? In the rotor sense. And the cutoff speed is such that after which there is no generation. Whatever you do, it will not allow to deliver power. This is the cutoff speed. After that, this power went to 0. This is the cutoff speed. So there are three types of speed in between. Cut-in speed, below which no power generation. Rated speed is such that rated power generation, and the cutoff speed above which there will be no wind generation, then no power generation. And there is comes a concept of vertical axis wind turbine and the horizontal axis wind turbine. Vertical axis, horizontal axis, such that you can see this is two types of windmills can be possible, that is the 3 blade system. This is perpendicular to this earth surface. This is horizontal axis vertical turbine, horizontal axis wind turbine. If you see a certain wind turbine which is mounted parallel to this surface, this is the vertical axis wind turbine. Two types of wind turbines are there, and from this you can say that, suppose I am getting to the first option, that is the more efficient. Which is the more efficient? At the low wind speed. If you see at a low wind speed, it will come, then vertical axis will rotate, and the horizontal axis at a low wind speed it will not generate. So from this option there, vertical axis blade more efficient. It is not correct. That is the horizontal axis wind turbine is more efficient at a low speed case, and vertical axis wind turbine has a blade that rotate parallel to the ground. That is actually vertical axis. This is horizontal axis. This is vertical axis. It is parallel to the ground. That is correct. And horizontal axis wind turbines are generally more suitable for urban environment due to their compact design, and this is false. Horizontal axis wind turbine takes larger area as compared to the vertical axis wind turbine. Okay, and the vertical axis wind turbine experience less turbulence. That is false. Horizontal axis will require more turbulence. Why? Because it is at a higher wind speed locations. It can be onshore or offshore, and the horizontal axis are more cost effective. That is not correct. It is mounted at a higher level, so it is also cover a larger area, so it is more costly as compared to the vertical axis. Vertical axis mainly suitable for this urban environments. Let's come to this last topic, that is the doubly fed induction generator. Why? Because there are many this wind turbines are there, wind turbine based generation systems, but I am considering this because it have a most relevant application in the present scenario at a higher power level. If you see, this is the this wind turbine fins, and then it is connected to the wind turbine, then there is a gearbox as I have shown, then is connected to a stator, then rotor, and rotor is connected to this stator is connected to this grid, and the rotor is connected to this parallel branch, then it is connected to this distribution transformer, then the total power then connecting to the grid. If you see, let's take an example. This is a stator and this is rotor. What I have said, this stator is connected to the grid, and the rotor is also connected to grid through a parallel fashion. It is also connected to the grid, this rotor and the stator, and it is going to the grid. Okay, this is the shaft, and in between there is a one controller. Suppose first coming to this subsynchronous condition. Subsynchronous condition, it means that omega m is less than the omega s. Omega, what is omega s? That is 120 f by p. If it is lower, and this shaft, this stator is generating certain power, this mechanical power, and this rotor is also generating certain power, which is taking this power. But and this is the air gap power which is going to this grid. What will be the mechanical power? It will be 1 minus s times of Pg. So stator from the shaft which is coming mechanical power is 1 minus s Pg, and it is going from the here to the grid, that is Pg. So where the SPG is coming, so SPG should go here, no, come from here, SPG from the controller side, from the grid itself. So this rotor is of variable frequency. Variable frequency, why? This is a variable speed is there. So in the subsynchronous case, it takes the power, that is SPG, from the grid itself to maintain a certain speed level, to generate a constant level of power, that is Pg. This is condition of this subsynchronous. At that condition, S is greater than 0, and if you see this P mechanical receives machine receives P mechanical. It is also saying that it is flowing from here to here, and machine delivers power via rotor. This is also delivering power via rotor, and the machine receives power from the rotor. It is also receiving power because SPG. If you sum up this SPG and this, it will go in. Machine receives rotor via the rotor. This SPG, it will come out to be 1 minus s times of Pg. It will sum. If you sum this, it will come to the Pg. It means that mechanical, it is coming 1 minus s times of Pg, and it is going Pg and also coming SPG from where? From the rotor side. If you see from this supersynchronous case, at that point omega is greater than omega s is less than 0. It means that 1 plus s times of Pg will be generated, because speed is more than what it desired. So SPG should be go inside of the rotor, and the Pg is constant to maintain to go to the grid side. Extra SPG should be go from this controller to the grid side. Okay, so the rotor side, the constant power is being maintained. Stator side, the Pg is maintained by injecting the extra SPG to this from the rotor side. So this is a concept of the generator unit during this subsynchronous and the supersynchronous conditions. Okay. In this condition also, you can say the mechanical power. Machine receives mechanical power. It is receiving mechanical power, and machine deliver power via stator. It is also delivering power from the stator, that is Pg, but it is also saying machine delivers power via rotor also. It is also delivering rotor power from the rotor, that is SPG. That is the main concept behind this doubly fed induction generator, because you have a two part to control this speed and maintain a constant
Actually,
power.
sir, one doubt, sir. May I ask?
Yeah, sure.
Actually, sir, synchronous, induction generator. Basically, less than synchronous speed, the slip is whether less than 0 or greater than 0. In both cases, it works as generator.
No, actually NR is, what is NR? NR is NS 1 minus
speed.
S. 1 minus S.
Yes.
Okay.
Yes.
Omega S, what I am saying that NS is the omega S. Omega S is synchronous speed. NR is omega what is being generated that by the machine. So if you see that if S is less than 0, it means during the subsynchronous case, S is greater than 0 during the subsynchronous case, it means that NR is less than NS. Okay, so this need a certain power to maintain at this synchronous speed NS, that is fed from this rotor side, that is SPG. And if you see from the super synchronous case, that is the NR is NS 1 plus S. It means it is generating more than what is being desired. So you need to deliver this SPG from the external path. This SPG is given from the rotor side to the controller, then to the grid.
Okay, sir. Thank you.
Okay. This is the
Yes.
you can ask.
Yeah. No, actually, generally for the induction machine, if sleep is less than 0, it works as generator. If sleep is greater than 0, it works as a motor.
But there
we inject.
yeah.
But we inject air from rotor side.
Yeah. But here you
Thank you,
can
sir.
see
Thank you
there
so
is a
much.
speed is variable. You can
Yes.
you don't have any control on the speed. It is variable. So you need a certain mechanism which can settle down to a certain level. Okay.
Okay, sir. Thank you, sir.
Okay. So this is the last point which I have shown. This is the end of this lecture. If you have any doubt, you can ask me right now. Any doubt? If you don't have any doubt, we can stop the session here
So
because it is
really, thank you so much, sir, for this valuable session.
yeah.
Really, we got a lot of clearance.
Thank you,
By
thank you very
yes,
much.
you're
Thank
yes, sir. Thank you.
you. Okay, I'm stopping the session. Thank you very much, guys.